Hey, welcome back, everybody. We are continuing chapter 5. This is sort of a big one here. We're going to graph these rational functions. These are the most complicated functions to graph. I think if you asked any math teacher, they would agree with that. Now, when we are doing this, we need to keep several things in mind. What's the domain? And when we ask domain, what we're asking actually is what value in the denominator is going to make the denominator equal 0. So we'll just keep an eye on that. We'll find the intercepts. If there are any holes, look for vertical asymptotes, horizontal asymptotes, using the tools that we had in the previous video. And the sign graph, if they give us the signs, great, we'll use them. If not, the next video, 5.4, is a video that shows you exactly how to find those signs. But let's go ahead and recall that the Y-intercept is when x equals 0. And the X-intercept is when y equals 0. And for this one, you'll have to factor. Cancel. Now, if nothing cancels, then you don't have any holes. If something does cancel, then there's a hole there. Vertical asymptote, again, this is where we let the denominator equals 0. And this is those three cases, meaning the degree of the numerator versus the degree of the denominator. And I'll review those as we move forward. Behavior of a graph around a vertical asymptote. So if we have something like this, and we have a vertical asymptote, say here, the way the behavior is going to look, it's going to look something like this, or something like that, or it could be on the other side going up, the other side going down. It really just depends. And we'll definitely have to keep an eye on that. Behavior around horizontal or slant asymptotes is going to, this isn't too difficult. And so what it's going to look like is here. So we'll have a horizontal asymptote. And the behavior is going to be something like this, or like this, something to that effect. And for what we're doing, they're not going to cross, but occasionally they can actually come and pop up over and then become an asymptote like that. But again, for this course, I don't think we're going to run into any of those. Now, a slanted asymptote is going to end up with something like this. So this is the horizontal asymptote. The slant meaning we have some sort of a slant asymptote like that. And the way the graph behaves, it could do something like this as it's getting closer to it, or it's could be coming down here like this. But other than that, it's not too bad. Let's move on here. All right, so we are just going to plunge into this. So here we go. I'm going to start with A. I'm going to factor that function completely and pull a -2 out, and then it factors into x plus 6, x minus 2 over x minus 7, x plus 2. So we definitely don't have any holes. We can see right away that there's nothing that's going to reduce. Let's start with the domain. So I'm going to go down this list here. So the domain is going to be everything except 7 or -2. 2, Here's our domain. Also, that's where our vertical asymptotes are going to be. So our second part is going to be the Y-intercept. Again, that's when x equals 0. And we can see right away when x equals 0, those are gone. Those are also gone. We're going to get negative 24 over 14, which should reduce to negative 12 over 7. So the point 0, negative 12 over 7 is our Y-intercept. Part 2 will be our X-intercept. There's no holes, we already established that. So X-intercept, again, that's when Y equals 0. So we have negative 2, x plus 6, x minus 2, over x minus 7, x plus 2. And I'll let you in on a little hint. It's basically what makes the numerator equal 0. So I multiply through, divide the negative 2 out, I end up with x plus 6, x minus 2 equals 0. It looks like our x-intercepts are going to be negative 6, 0, and positive 2, 0. Now, these are all points on the graph, so that's going to be helpful. And in fact, for the y-intercept, let's see what that's about. So 12 divided by 7 would be 1.7. Okay. So this is about negative 1.7, just to keep that in mind. 3, 4 is the vertical asymptote. Vertical asymptote says 4. Vertical asymptotes are at x equals 7, x equals negative 2. And finally, our horizontal asymptote. Now, here's the thing. Go back to the original here. You can see that they are the same degree in the top and the bottom, which means the lead coefficient, negative 2 over 1, is going to be my horizontal asymptote. So that's going to be y equals negative 2. Once again, because negative 2 over 1. So this is taking up a lot of space. Let's put the graph here. I doubt I'm going to get all 3 on the same page. All right, let's start with the vertical asymptotes at 7 and negative 2. All right, and we have a horizontal asymptote at negative 2. We have some points that we can put on there that are actually on the graph. So y, negative 1.7, so that's about there. And for x, we have negative 6. So put that here. Negative 6, we are crossing the x-axis. And at 2. 2. All right, so here is what I am seeing. I'm seeing a graph that's doing this. I'm seeing a graph that's doing this. Now this one is going to cross the asymptote. It's the extremes that where they become the asymptotes. So the one in the middle, not so much. Then I'm seeing that there because there's no other X-intercept, so it can't be up here. That is A. Let's see if I can throw B in there. And then C I'll have to use on another piece of paper, probably. All right, part B. So let's set this up. So it looks to me like our function factored, that's g of x, is going to be x minus 3, x plus 2, is that 3? Over x minus 2. Okay, so our domain, first of all, nothing reduces out. So our domain is everything but 2. So part 2 is the y-intercept. The y-intercept is when x equals 0. We can see right there when x is equal 0, I get -9 over -2. So this is going to be 0 and then 9/2. And keeping in mind, 9/2 is 4.5, just as a reference when we go to graphing. Next up are the x-intercepts. That's when y equals 0. So if I have x minus 3, x plus 3 equals 0, as I mentioned before, we just want to know where the numerator is equal to 0. So it looks like we're getting x-intercepts at plus and minus 3. So 3, 0, -3, 0. Part 4 is going to be the vertical asymptotes. Vertical asymptote at, so vertical asymptote specifically at x equals 2. And horizontal asymptote is going to be at, now there is no horizontal asymptote, however, there is a slant. So what I'm going to do is I'm going to take my previous page and do some long division there. So x minus 2 divided by x squared plus 0x minus 9. So that's going to be x squared minus 2x, 2x minus 9. That gives us -5. But what's more important is our slant. Slant asymptote is y equals x plus 2. All right, so let's see what this graph is going to look like. So let's start with the asymptotes. Vertical asymptote at x equals 2. We have a slant asymptote at y equals x plus 2. So that's looking to me like we're going to have a point here and a point about right there. So that's going to give me that right there. We have intercepts at +3. So here's 3. And at -3. -3. So we have a point here, and we have a y-intercept at +4.5. So it's 4.5. So I'm seeing something like this, something like that. Let's see And so this graph will never cross the vertical asymptote, right? Part C, I'm going to rewrite factored. So C, h of x is 2x minus 7, x plus 3. We have x plus 3, x plus 5. All right, we have a hole. So let's write this out first. First of all, x cannot equal -3 or -5. So for the domain, it's going to look like this. So there's our domain. We have a hole at x equals -3. So our function now looks like this. 2x plus 7 over x plus 5. So we're going to graph this, but we're going to have a hole. Now, when I put -3 into here, h of -3, now that we've reduced them out, we can see what that would be if it were an actual point, but it's not, it's going to be a hole. So 2 times -3 minus 7 over -3 plus 5. -6 minus 7 is -13 halves. All right, so we have a hole at the point -3, comma, -13 halves, and just make sure we're on board, that is -6.5. So we can have a better idea of what that means. All right, let's talk asymptotes here. Vertical asymptotes. We do not have one at x plus 3, but we have one at x equals -5. Horizontal asymptote. Again, the degrees are the same. So we're going to have a horizontal asymptote at y equals 2 over 1, which is 2. And let's see what that looks like. So we have a vertical asymptote at -5. Let's go here, -5. Horizontal asymptote at 2. We have a hole at the point -3, -6.5. So we'll go here, -3, -6.5. Oh, we haven't found the intercepts yet. That's okay. So let's find the X-intercepts. So Y-intercept, x equals 0 at -7/5. Y-intercepts at X-intercepts, at, that's when y equals 0. Again, that's where the numerator equals 0. So it looks like we're going to be at -7 halves 0. And -7 halves is -3.5. So let's put those in as well. Let's put the hole in first. So our hole will go right there. Also, our y-intercept is -7/5. Let's see what that looks like. 7 divided by 5, 1.4. So -1.4. And our x-intercept is at -3.5. So we are going to be about right there and there. This should be a +7 halves. Again, that's what makes that. So actually, 7, that's, oh, so that dot's not right. So this one here is going to be the positive 3.5. But here, so 3.5. So I'm seeing something like that. And then we are also going to have this over here. I know it has to be there and it can't be down here because I don't have another intercept. So that's about a good dot there. Whew, that was a lot of work. That's only page 2. All right. Pardon me, that was, yeah, page 2. So we are on to this page next. More on graphing rational functions. So now we're going to have the signs that we mentioned before. All right, so we are going to, let's draw. So we are going to have a horizontal asymptote at 2. Vertical asymptotes at -1, -1, and +3. All right, no holes, okay. X-intercept is at 5. So this will be 5 here. So let's extend that further. X-intercept, there's only 1. Y-intercept is at -4. And positive, okay, so from -infinity to -1, y is positive, it's bigger than 0. That means we're up here. Because it's not going to be down here because we would be crossing the x-axis, and there's only one place that we cross the x-axis. Okay, so from -1 to +3, we are negative, so we're not up here. We're down here, and we're not going to cross the x-axis. So I think we're going to get something like that. Because it can't cross the x-axis, there's only one place it does then. From 3 to 5, it's from 3 to 5, it's negative. Okay, oh, I see. Then after that, it's positive. Not so bad. All right, let's try this one next. All right, so we have a slant asymptote at -3 up to /1. So we have a slant asymptote about, what was it? 2, so it's a little steep. All right, we have no vertical asymptotes, okay? We have a hole at 4, 1. So that's going to be, I'll say this is 4, here's 1, and here is our hole. All right. And we have an X-intercept at 3, 0. A Y-intercept at -5. So I'm seeing a pattern here. It's looking like it's going to do this and come up through here, and bounce off, something like that. Oh, I need to take this into account. So let's hope that I'm right. From negative infinity to 3, it's negative. It is. So it's negative. Good. And then from 3 to infinity, it's positive. Perfect. All right. This last page, I don't do any work, but what I'm going to do is I'm going to walk you through kind of how you would be given a graph and how you would have to kind of piece together what it's going to be. There won't be any homework questions like this, but this is just more of an extension. So here we have a graph, and we want to try to build, if possible, a function from this. So since our asymptotes here are at -2 and +1, x equals -2, x equals +1. And for this first one, we know there's an asymptote at -2, which means x plus 2 is going to be a factor in the denominator. Now, the fact that this one's going up and this one's going down, they're going in opposite directions, means that the exponent on that has to be an odd exponent. So we'll just keep it simple. We'll just keep it x plus 2 to the first power. Now, over here, they're going to infinity in the opposite direction. That means that it's going to be an even exponent, so we may as well just make it x minus 1 squared. Let's keep the degree as down as we can. We can see that it's crossing the x-axis at 3. That means the numerator is going to have the factor x minus 3. Now, because because we have a horizontal asymptote, let me draw that in. In fact, here's the vertical. And we have a horizontal asymptote at x equals 2. This is y equals 2. So we know that the lead coefficient is going to have to be a 2. We'll get to that. And because it's not at 0, what's happening is, meaning our horizontal asymptote is not at 0, what that tells us is that the degrees on the top and the bottom have to be the same. So in the numerator, we have to put a term that will not equal 0, any term. So x squared plus 1 will never equal 0. And look, it makes it 1, 2, 3, degree 3, and in the bottom, it's 1, 2, 3. So now the degrees are the same. Now, because y equals 2 is the horizontal asymptote, we need to put the 2 there. So this ends up being a potential equation for this graph. I know this lesson is very complicated. You may need to go back through it at some point. Good luck.